Hi, I'm Teoh Ying Fan with metric number 179791. Now, I'm going to present my final year academic project with the title Autonomic Control for Laboratory Experiment using Single-Board Computer and Microcontroller. Autonomic process control is very important in a plant to achieve a desired production, economy, and safety. Therefore, the controller should be properly chosen in order to achieve the stability of the plant. PID controller is widely used in industries because it is flexible and easy to use. However, many industrial processes characterized by highly nonlinear dynamics and parameter uncertainties do not give satisfactory responses using conventional controller. While fuzzy logic controller is believed to have better performance in controlling nonlinear systems compared to PID controller. Fuzzy logic is used mostly to handle high-level control functions that traditional control methods do not address. Therefore, in this project, PID controller and fuzzy logic controller are studied and their performance are compared. The main objective of this project is to compare the performance of conventional PID controller and fuzzy logic controller for process control experiment using single-board computer and microcontroller. The specific objectives are to develop the theoretical model for the process control equipment and analyze the dynamic behaviors. Secondly, it is to determine the PID parameters for different PID tuning methods using theoretical model developed with the help of MATLAB Simulink. Lastly, it is to compare the online process control performance, such as response time, set point overshoot, and steady-state error for both PID and fuzzy logic controller. Now, I'm going to present about the methodology of the project. Firstly, the equipment are set up and the empirical data is collected with the step response introduced to the system. Then, theoretical process model is developed using first order with time delay model, and MATLAB simulation for both PID and FLC are done, but PID is simulated using MATLAB Simulink, while fuzzy logic controller is simulated using MATLAB Fuzzy Logic Toolbox. Then, the Arduino programming are uploaded into Arduino Uno for real-time control. Lastly, data analysis and performance evaluation are done. This picture shows the device connection, while in embedded there is the Arduino Uno, which is the single-board computer and microcontroller used in this project, while the green one is the ultrasonic level sensor, and the side and the two pumps are arranged in parallel at the right side of this picture. There are 4 PID controller tuning methods tested in this project. Firstly, internal model control (IMC). Secondly, internal model control with integrated approximation. Thirdly, internal model control Scholl-Start. Lastly, Ziegler-Nichols tuning method. While the fuzzy logic controller are designed based on the membership functions for inputs and output. The inputs include error and the rate of change of height, while the output is the pump speed. Then, these are the fuzzy rules used to design the fuzzy logic controller. As an example, to read the table, when the error is negative small, and the delta H is negative small, and the pump speed should be negative small. Then, I would like to present the results and discussions. So in part A, process model identification, we obtain a graph of a step response of the process output. The Y, which is represented by the blue lines, show the actual measurements of the sensor, and the yellow line is the Y bar, which is the corrected process output. From the graph, we can see that the sensor consists of a lot of noises, which causes the disturbance to the process. Also, From y bar, we obtain the transfer function with process gain of 2.8813 with time delay 2.9997 and time constant 694.3435. Then we can draw a conclusion that the time constant is very big compared to time delay, and then this also means that the process is a lag dominant process, which is a very slow process. So in part B, simulation for different PID tuning methods. For the first one, IMC, different tuning parameter TC is tested, while the one that gave the best result is TC equal to 3 with 0 overshoot and 25 settling time. Next, IMC with integrated approximation has overshoot 4.5 and settling time 55. IMC Scotchestat show overshoot 3 with settling time 85 seconds. And Ziegler-Nichols has an overshoot of 16 and settling time of 55. Summary of PID tuning methods are shown in this table. As we can see, IMC shows the best result. This is because the simulation is only based on single step change in set point with the assumption of the sensor block transfer function is 1 and no disturbance is introduced in simulation. However, the result should be validated with the online process control later. In part C, simulation for fuzzy logic control, with the membership functions and fuzzy rules described in methodology. Now, we have the simulated result in two ways, which is rule viewer and surface viewer. So, rule viewer allows user to slide the red slider to left or right, and it gives the corresponding pump speed value according to error and delta H. While surface viewer is a 3D graph allow user to find out the pump speed value. In part D, online control performance comparison using PID controller and fuzzy logic controller. First one, this is a graph of height of water level measured against time for IMC tuned PID controller. No overshoot is observed with settling time of 496 seconds and steady state error of -3. And then this is the graph show using IMC with integrated approximate tuned PID controller. It gives a faster response compared to IMC with a settling time 3 to 7 seconds and no steady state error. Then, IMC Scotchestat tuned PID controller show a settling time at 259 seconds with a steady state error +1. And then, this is Ziegler-Nichols tuned PID controller with a settling time of 288 seconds and no steady state error. And then this one is fuzzy logic controller with settling time 105 seconds and 0 steady state error. So these show the summary for PID and fuzzy logic controller. So among PID controller, Ziegler-Nichols is the best tuned PID controller with no steady state and relatively short settling time, while IMC become the worst PID tuning method. This is because IMC is not good in rejecting disturbance, while the sensor causes a lot of disturbances into the system. And then all controllers show no overshoot because of the slow process nature. And then the best controller all in all is fuzzy logic controller. It has shortest settling time, which means the controller responds the fastest and no steady state error. This is because a fuzzy logic controller is designed based on the operator opinion, which the membership functions and fuzzy rules are properly designed. Also, fuzzy logic controller is a form of artificial intelligence, which is a rule-based system that can rely on the practical experience of an operator. However, many trials are attempted in order to obtain a highly accurate fuzzy logic controller. As a conclusion, the theoretical model is developed, which the transfer function has a process gain of 2.8813 with time delay 2.9997 and time constant 694.3435, and the process is a very slow process. Secondly, PID parameters for different PID tuning methods are determined using theoretical model developed with the help of MATLAB Simulink. Thirdly, compared with PID controller, fuzzy logic controller has the shortest response time and no steady-state error on the real-time control. However, overshoot response is not able to be investigated in this project. There are three recommendations for this project. Firstly, control valve should be used to replace pump. In industry, control valve is used to control the flow rate, while pump is normally used to increase the pressure or flow rate. Secondly, a faster process system should be designed. This is because a faster process system should be able to help the researcher to find out the overshoot response for the controllers. Thirdly, a second-order system is also more interested to be studied. This can be done by adding another tank in parallel so that a second-order system can be created. That's all from me. Thank you.